Welcome to the tutorial for exponent laws. The first one we're going to talk about is the product of powers. The generalized law is a to the m times a to the n. It's the same as saying a to the exponent m plus n. Why is this true? So let's look at the example of 2 squared times 2 to the cubed. And what they're saying is that equals 2 to the exponent 2 plus 3. And why is that true? 2 squared is 2 times 2. We're multiplying that by 2 cubed. That's 2 times 2 times 2. If we add them up, we have 1, 2, 3, 4, 5. So in total, I have 2 to the 5. And if we look at this, our exponents of 2 plus 3, that equals 5. So, that is true. It equals 2 to the 5. Those are the same. Next, we're going to look at the quotient of powers. So, the generalized statement is a to the exponent m divided by a to the exponent n is the same as saying a to the exponent m minus n. And a cannot equal 0. And that's because we have a base of a in the denominator of our fraction. So why is this true? Let's look at our example of 2 squared and 2 cubed. So we'll put 2 cubed on the numerator, and I'll do 2 squared in the denominator. Well, that's also saying I have 2 times 2 times 2 in the numerator, and 2 times 2 in the denominator. Well, I have these two are the same, and I have these two are the same. So that's telling me that I can cancel those out, because 2 divided by 2 is 1. 2 divided by 2 is 1. So that leaves me with just a 2 on the numerator. Well, let's look at it. It's 2 cubed minus the exponent 2. Oh, that does equal 2. 3 minus 2 is 1. And look, those are now the same. The third one of the exponent laws is the power of a power. So what exactly does that mean? It's a to the m all to the exponent n. And what they're saying is we can multiply our exponents. So that means that it becomes a to the m times n, or it can be written as a m n. So let's look at the number 2 again that we've been using in our examples. So if we have 2 squared, and we're saying it's cubed. So based on this rule, what they're telling me is I need to multiply my exponents. That's 2 times 3. So that gives me an exponent of 6. Well, how do I know this to be true? Well, 2 squared is 2 times 2. And they're telling me I need to have 3 groupings of it. So that's 1. So I got to multiply it again by another 2 times 2. And I got to multiply it again by another 2 times 2. So now I have my first grouping, my second grouping, and my third grouping. Well, look, if I add them up, there's 1, 2, 3, 4, 5, 6 2's. Well, that does equal 2 to the 6. Those are the same. The fourth law is the power of a product. This means we have 2 different bases. So I have a times b all to the exponent m. And what they're saying is that equals a to the m times b to the m. Let's see if this is true. Let's look at our example of we're going to have 2, and I'm going to use an x just for something different. And I'm going to say that we're going to multiply it to the exponent 3. So what they're saying is this equals 2 cubed x cubed. Well, how do I know this? Well, let's look. The exponent is telling me I need 3 groupings of my base 2 to the x. So I have 2x times 2x times 2x. I'm going to collect all my like terms. So I have 2 times 2 times 2, and then I have times x times x times x. Well, look, there's 1, 2, 3 2's, so that's 2 cubed, and I have 1, 2, 3 x's. That's x cubed. Oh, look, these are the same. The power of a quotient. So now we're looking at using the two different ones. So we'll have an a and a b, but this time because it's a quotient, we're looking at dividing L to the exponent m. So now it's telling me I have a to the m over b to the m. And of course, b cannot be equal to 0 because it's in the denominator. So if we take 2/3, and I'm going to use 5 as the exponent. So it's saying then that it's 2 to the 5 over 3 to the 5. Well, let's look at it. The exponent tells me, again, how many groupings I need of this whole expression. Well, the expression is 2/3. So it's saying I need 5 groupings. So that's 1 times 2/3. That's 2 times 2/3. That's 3 times 2/3. That's 4 times 2/3. That's 5. So what I'm going to do is separate it out. So I have 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Yep, okay. There's 2 to the 5. And then I have, it's multiplied by 1/3 times 1/3 times 1/3 times 1/3 and one more times 1/3, because they're saying I have 5 of them. Well, if I times that by 1/3, that is to the 5. So, and because it's a numerator and denominator, it's 2 to the 5 over 3 to the 5. Because the 1/3 can also be written as 1/3 to the 5. Because 1 to the 5th is still 1, correct? So again, we have 2 to the 5 over 3 to the 5. So those are exactly the same.